All right, you little mathematicians, here is an introduction to dot plots. Okay, dot plots. These are very important, awesome, simple ways to represent data. Imagine this statistical question. How much do mice weigh? Well, we would weigh some mice and record the weight in grams in the table. And we display it in a dot plot, and then we're going to identify any clusters, peaks, or gaps in the data. All right, so what's going on here is we have a number line, right? Just a number line. We know it's counting weight in grams. So you can see 18, 19, 20, 21. Every time we find a mouse that weighs 18 grams, we put a dot here. We find another mouse that weighs 18 grams, we put a dot there. So we can see 2 mice weighed 18, 3 weighed 19, 6 weighed 20, 0 weighed 25, right? And then we can look at this data. It's pretty interesting. We can see there's a cluster of weights around here. Most of the mice are somewhere between 18 and 22. And as you can see, there's kind of this curve. That sort of curve is very important in statistics. You'll learn much more about it in the years to come. It's called a bell curve. And we can see this is a cluster. Here's the peak of that cluster, the highest point. There's a huge gap here. And then we have basically these 3 huge mice, right? I don't know if they're fat or just bigger than all the rest, but they weigh significantly more. So these 3 out here we would call outliers. Some of you might have actually heard this word lately. Outliers, these ones. Because they lie way outside of our main cluster, right? They literally just lie outside of the main cluster. They're called outliers. So here's another dot plot. This shows the times of 6th graders in a 100-meter race. So here you can see all the data points. And really we're looking at a short span here between 13 and 14, right? So here are a few questions you might be asked about this. 1. How many students ran in the race? Well, that's just simple counting, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 students ran in the race. How could I have collected this data, and what are the units? Well, one way you might have collected this data is by literally just going to the track with your stopwatch and, seeing the times it took everyone. Another way could be asking the track coach, because track coaches usually keep records, right? Different ways we might collect the data. Maybe we would just ask the runners themselves what their times were. And what are the units? Well, this just requires you to sort of think. It's a 100-meter race. That's about 100 yards. To keep that in perspective, a mile is about 1,700 yards. So this is much, much, much shorter than a mile, and these kids are obviously sprinting as fast as they can. 100 meters, about 100 yards. We're probably not talking about minutes here. We're probably talking about seconds. So statistics, it's a super useful tool. It gets used all the time. Thinking about sports, if you're anyone who watches sports, stats are one of the most important things that coaches use to find out how their players are doing and, what players they want to have on their team. So we're going to look at a ton of different ways of representing data. We've seen dot plots, our first way. I'm really excited for the next few weeks. Hope you are too. Thanks a lot. See you in class.